Hi everyone, welcome to Mathspar. This video is about tangent and chord properties of circles. So, before we look at the theorems in this topic, let us have a recapitulation about what is a tangent. A line drawn to a circle in such a way that it touches the circle at exactly one point is tangent. So, in a circle, if a line segment is drawn in such a way that the line segment is having the end points on the circumference of circle is called as chord. Suppose if the same chord is extending on one side or on two sides, then it is called as secant of a circle. So now let us learn some properties over this tangent, chord and secant of a circle. So mainly we call this as tangent and chord properties of circles. What does the first theorem states? So first, if we draw a circle and a tangent, so if you draw a chord, now the theorem speaks about the angle formed by the tangent drawn to a circle and a chord will be equal to the angle formed on the remaining circumference with respect to the same chord will be equal. That is, the angle formed between the chord and the tangent of a circle is equal to an angle in the alternate segment. Now this chord is dividing this into two segments. This is minor segment and this is major segment. So these two are equal. How do we prove this? Let us have a look. Let us draw a circle and now a tangent is drawn that touches the circle at point P. Then a chord is drawn, that is PQ. Then we will draw the diameter of circle, assuming PR is the diameter of circle. Then if we look at this particular figure, if I join QR and C, then I find that this particular angle is 90 degrees. That is, angle PQR is equal to 90 degrees because angle in a semicircle is a right angle. Now we know that OP is perpendicular to, if you consider this as AB, OP is perpendicular to AB. Why? Because the tangent at any point of a circle and the radius through the point are perpendicular to each other. Then if I assume this angle as theta, that is, let angle QPB is equal to theta, then what will happen to this remaining angle, that is angle RPQ will be equal to 90 minus theta. When this complete angle is theta and this became, when this complete angle is 90 degrees and when this becomes theta, the remaining angle becomes 90 minus theta. Then in triangle PQR, 90 minus theta, this angle, plus 90 degrees, this angle, plus the remaining, that is angle PRQ. The total sum will be 180 degrees, because sum of all angles in a triangle will be 180 degrees. Then you observe that here 90 plus 90 is 180 minus theta plus PRQ is equal to 180 degrees. That is, this 180 minus theta you take it to the other side. Then 180 degrees as it is here, plus 180 if you send it to the other side it will become minus 180, minus theta if you send it to the other side it will become plus theta. Minus 180 plus 180 gets cancelled, then angle PRQ is equal to theta. Then this particular angle has become theta. So by this we can conclude saying that the angle formed between the chord and a tangent drawn to a circle will be equal to the angle in its alternate segment. So because the angle subtended by this tangent with respect to this chord, so the angle between the tangent and a chord at this particular intersection point will be equal to the angle formed on the same chord in the alternate segment. So this theorem is named as alternate segment theorem. This theorem is named as alternate segment theorem, and this stands as the proof for alternate segment theorem. So now when a chord and tangent intersect each other externally, then let us draw a tangent, a point of intersection marked as P. Then let's say that the chord is produced to intersect the tangent at P. That is, actually now AP is a secant. So now this property is also called as tangent and secant property of circles. So when a chord produced and a tangent are intersecting each other externally at point P, then the product of lengths of the segments of the chord, segments of the secant rather, will be equal to the square of the length of the tangent. So we have to prove that AP into BP is equal to PT square. How are we going to prove? Let us join AT and BT. we have joined AT and BT. Then if you observe here, this is the common angle for both ATP triangle and BTP triangle also. Then we mark this particular angle theta will be equal to this angle theta by alternate segment theorem, what we have learned in the beginning of this video. Alternate segment theorem, these two angles are equal. Now if I draw two triangles, I will mark the first bigger triangle as it is ATP, then I will mark these angles theta, common angle. So here also I will mark theta and common angle. In this triangle, where is the common angle? Common angle is at P. So let us mark this as P. Then the angle theta is at T. So mark it as T. Then the remaining vertex is B. So let us mark it here. Then we write that angle APT is equal to angle TPB. Why? Because those two are common angles. Then angle TAP is equal to angle BTP. Why? By alternate segment theorem. Then we say that triangle ATP is similar to triangle TBP by angle-angle similarity. Then when two triangles are similar, their sides are proportional. So we write AT by TB is equal to TP by BP is equal to AP by TP. Now these two, then AP into BP is equal to TP into TP, that is AP into BP is equal to TP square. Hence we have proven that when a tangent and a chord produced are intersecting externally, then the product of lengths of the segments of chord produced will be equal to the square of length of the tangent. Thank you.